Paul. I'm a software developer at Schrodinger, and starting in the March release of rdkit, we added some templates for coordinate generation. So just a little bit of background if you're not familiar with generating 2D coordinates for like looking at pictures of moles. There's two different methods. The first is using like rdkit's native coordinate generation, and then there's also something called CoordGenLibs, which is software written by Schrodinger that you can use through rdkit by setting set prefer CoordGen on RDDepictor, which I think by setting this to true. So the templating that I'm showing here is using rdkit's native coordinate generation. So the set prefer CoordGen has to be false to use this. And to use the templates, you just set use rings templates to true. So also last year, I gave a presentation on the difference between like these two methods. And so if you're interested, you could probably find those slides in last year's GitHub. So here's some examples of templates. Their best use is with like fused ring systems where rdkit's coordinate generation just doesn't look great, and there's a specific way we want to lay out the molecule. So these are examples where the exact structure we're generating coordinates for is just the template itself, but you can also do it within larger structures. So like this has chains. So the templates themselves have to be ring systems. They can have spheroid rings, but no like bridge ring system. So for example, this whole structure right here. Oh, can you see my mouse? Yeah, that can't be a template. Yeah, and so here's some examples where there's two template matches within a structure, or three, I guess, in this scenario. So you can also set custom templates. There's two ways to do that. The first is to like add an additional ring system template on top of what we already have included. And to do that, you can use this add ring system templates on RDDepictor, and you just pass in your molecule that has a 2D conformer with the like layout that you want matching structures to use. And then the other way to do it is to use this set ring system templates function, and that you will make a .smiles file where every line is a CX smiles representation of your template, and then you just pass the file path into this function, and all of those will be loaded in. And just a note on like performance for this. So the templates are actually loaded in at runtime the first time you use the templating, which is that. So the first time you use this argument, use ring templates. So the very first time you call it, it will be a little bit slower if you're timing it, or if you're really good at seeing how fast a line of code runs. But after you use it for the first time, then it should be a little bit faster than what we had before. So this is just an example of where I changed the templates to a different path. So this one on the right here. All right, so there's a few limitations right now with these templates. This is just kind of our starting point. In the future, I think it would be, we want to be able to choose the attachment point where other branches would come off the template. So like in that structure up there, you can see that it would be probably better for that chain to come off this corner, maybe one on the bottom. And then another thing that we're going to work on is macrocycle templates within larger ring systems. So right now, some of the templates do include macrocycles, but since the entire template has to match, we don't have like macrocycles that will, where you can like template half of a fused ring system. So that problem is kind of similar to this one. And then, so we set up another repository so that people can contribute and add more templates. And let me go here. Okay, cool. So here it is. And it's pretty easy to add a template. All you need to do is make a pull request to this repository, add your CX smiles to a file, and Ricardo set up some cool GitHub actions that will comment a picture of the template that you added. So here is an example. And all of these are nitrogens here because we didn't want them to clash with any of the existing templates. So when you're adding a template, make sure that you're not repeating any of the existing ones. Right now, there's around 70, and they're originally sourced from CoreGen. So here's the file change. So all you do is add a line with your CX smiles for the template you want. Yeah, so I think that's it. I'll be at the hackathon tomorrow if you're interested in adding some templates or giving some feedback. I think that there's there's definitely room for more templates here, and I think it would be helpful to even improve some of the existing templates that we have. Oh, I guess what I missed. There is a gallery file here with the pictures of all of the existing templates. So you can go through those. And then also, if you make a pull request with the template that you're adding, and then we merge it in, the GitHub action that Ricardo set up will then make a pull request to rdkit to add the template that you added to this repository. So, yeah. Yes, I'm done.
We have time for a quick question or two for Rachel, if there are any out there. Just yell, we can repeat it. Does the scaling matter?
So it doesn't, because we normalize it when we're like generating the templates, but that being said, I think that it will matter for, don't make a huge template, I guess. That's probably the easiest way, but it will work with any scale, I guess. But yeah.
Okay, thanks, Rachel. Paolo? The other thing on the templates, so Ricardo set up this great integration, so you see the new templates with the pull request. The other thing that is we had to cover, it automatically updates the other generate the pull request in the rdkit. So it updates the rdkit template, right? Yeah, okay, good. That one. And you are this one work? Yeah. One. I just put them up. Okay. Sorry, one second. Good.
Okay. Well, this is about a PR of mine dealing with MCS, refactoring and bug fixing. To cut a long story short, this PR has been open for more than 1 year because it's the kind of code that you can't really do when you have 15 minutes. You have to really get into that, and to get a significant lump of time to finish it was very challenging. And finally, what triggered finishing it was that it was an internal request for something that was getting caught into one of these bugs, and this gave me motivation to suffer through it until the end. So in the end, the PR was merged without any changes, which is not necessarily a sign of it being perfect, but of it being rather huge, as you can see from the number of changed lines here. So, but it doesn't break any unit tests, so we should be safe there. And the bugs, some of the bugs particularly involve performance. There are some troublesome compound pairs, particularly when you use complete rings only, that would lead the algorithm to run forever and slowly consume all of your machine memory without doing anything useful, and that's fixed. So that's all for the bug fixes. What I'm going to talk about are the new features today. So as this is something that I'm going to present, this is not actually a new feature. It's something that has been there for a while, but since I use it through the examples, I think it's better to refresh what it does and what it means. So as you may know, the MCS algorithm has a few built-in comparison functions for atoms and bonds, like to compare the element or compare anything, or compare the isotope or compare bond order, ignore bond order, these sort of things. But you may need to do something more specific, which is not covered by the built-in comparison functions. So you may want to build your own. And you can do that also from Python, while previously it was possible to do it only from C++. And to do it from Python, all you have to do is to implement your own class derived from the base class MCS bond compare and atom compare, and implement a call method which takes a defined set of parameters. So the MCS parameters, the two molecules and the two bonds or the two atoms, do the sort of comparison that you want to do, return true or false, and that will act just like any of the built-in comparison functions. The reason why it's not a pure function, but it's a class, is the fact that through that, you can also pass some static data, which is not necessarily tied to the specific couple of molecules that you're dealing with, but some more generic parameters which do not fit into the MCS parameters, but are something of your own. And you can put them in the class, and you can access them through the self parameter because they will stick to the instance. So if you do, for instance, a standard traditional MCS through these three molecules, what you get are two fuse cycles. And particularly in the case of the first molecule, actually, you can see that you might have two choices. Here, I only highlight one of them, but if I look at all the matches, I see that for the first molecule, I have a pair of matches. So if you decide instead to use a completely custom function comparison criterion, what I did here was just comparing orders and elements only when they are outside a ring. So I ignore element and order within a ring, and if I rerun that, I get a larger MCS because then all of these will match. And still, in the first case, I will have two chances of match for this ring system. If I want to restrict it further, this is what I'm doing through a custom parameter, and I can decide that I only want to match aromatics, and that's what I display in the following. Another thing which was not possible previously was the ability to retrieve all the generate MCSs. There may be cases where you have multiple MCSs with the same size within the same set of molecules. And previously, you would only get one. It's not a random one, because of course the algorithm is deterministic, but it's difficult to predict which one, because it will depend on the atom order in your molecule set. So what I did here was implementing instead an additional parameter that allows you to retrieve all of the MCSs if you're interested. So for example, if you look at this molecule pair, you can see that you have two choices. You can have the para and the ortho methyl aniline isomers. And by default, you will only get one. In this case, due to the atom ordering, you only get the para. But instead, if you set the generate smart query, store all parameter to true, then you have an additional accessor that you can use to retrieve all of the MCSs. Just one more second. Two more things, two checkers. So you can implement final checks on your MCSs, either while they are still growing or when they are still fully grown, or when they are already fully grown. So you can decide whether you want to accept or not. And this, again, may allow you to do more fine-tuning on what you come back. If you look at the examples, you will see how you can put it to good use. So I hope that can be useful. Thank you.
Thanks, Paolo. A suggestion to the community. So Paolo has a long history and is allowed to do giant pull requests like that, but please nobody else do anything like that to us. So if you have some large change you want to make, check with us first, please. Please, please. Michel, you ready? And then the last is a bit of a change of gears. So Michel, maybe you can introduce yourself and what you've done.
Okay. Yeah. I was planning to do it as part of the presentation, right?
And it looks like I'm smart.
So I'm Michel Moreau. I'm a senior software engineer at Valence Labs, and I'm also the the sort of the creator or the maintainer of the rdkit.js package. By a raise of hands, who installed or tried to install the npm package? 2, 3. Okay. But yeah, so I'm the author of the package. I just want to say that there's a distinction with the rdkit.js library, that there's the packaging of the actual core functionalities, and there's the core functionalities implemented in the minimal lib, JavaScript minimal lib, which is more on the side of, I would tend to say, Paolo. So yeah, so today I'm going to talk about things related to that are more on the packaging side than the core functionalities. So the current state and what we can do better from where we are. So this is not what's new or what's potentially coming talk. So introduction made, I think. So I'm going to skip the history part. I think the JavaScript library has been discussed in other talks, so for time efficiency, we can skip it. So the current state, I think since it's released, it has seen increased adoption, I would say. So we're now at 156K downloads per year, 91 stars. There's almost, I would tend to say there's weekly activity-ish on the repository, either through discussions, GitHub issues opened, code contribution, or other kinds. It's maintained, so every time there's rdkit release, there's rdkit.js release that comes with it. So if there's any change to the minimal lib JavaScript library functionalities, then it will be released as part of the npm package as well. So we have several examples in modern frameworks as well. And I just want to say that the decreasing slope is just because the year 2023 is not over yet. So we should see, at the end of the year, we should see a more straight line in terms of downloads per year or slope in the other direction. So some of the problems, I'll skip this slide and I'll address them one by one. To me, like the most important one, if we're missing time, is ease of adoption and difficulty to setting up the actual package in your project. So I'm going to dive right in with this. So many people on the forum have commented that it's actually quite difficult to get up and running with the project. I think it's because the documentation is quite disconnected with the way people tend to use it, which this is a guess, but the way people tend to start a web project nowadays is through web frameworks like Create React App or similar things that gives you a development environment out of the box, and you can import any kind of GS packages with import statements, and then you have live reload experience and stuff like that. But the documentation doesn't tell you how to set up the rdkit.js package, which comes with a WebAssembly module that needs to be placed at in your assets before you can start using it. And it's not obvious in a modern web environment where to place it. So, and even when you're actually set up with the rdkit minimal lib in your web project, if you really want to start doing real work, you still need to do the minimal lib is to this day very low level, so you still need to implement some components on top of it for it to be usable in a convenient way. So there are parts to it. There are a path to solving these issues to get to like a sort of a npm install then use experience. So as I was saying, if you use the main function that the low-level function that allows you to init, which is called init rdkit module, that allows you to initialize the WebAssembly module in a modern web environment, it probably won't work because you need, as I was saying, you need to place the WebAssembly asset at the right place for it to be loaded by the initializer. And I think for people with not enough or not a lot of web development background, this can already be can already be a blocker or a pain in using the library, and you may want to give up just there. So I think having the idea of a wrapper around this low-level rdkit module initialization that is sort of resilient. So if you do not provide the WebAssembly module yourself, then we're going to try to retrieve it for you in a certain way. So this is not official code. This is just a code for proof of concept, or just to let you know about the idea. And once we have that, we can add further abstraction on top of it, which I think one of the common cases using the rdkit.js package is for 2D molecular depiction. And then if you just want to use the package for certain use cases like this, do you really care about initialization, or you just care about rendering molecules? I think if we set the first building block, it will allow to just abstract initialization as well for purpose-specific components in different environments. So either pure JS or web framework environments. So the final thing to sort of achieve easier adoption in a real world context, I would say, it's just like pretty much all the ideas I presented are available here and there in the different efforts. And I think there's room definitely to centralize and organize all the efforts into something that's more cohesive. So the resilient minimal lib loader, as I was talking about, I think the de facto way to render a molecule in a performant manner that is client-side nowadays, the best implementation comes from Paolo with his project around the rdkit structure renderer. So can we use this as the basis? Because the context is also rendering molecules in the production context in cloud applications may seem trivial, but it's not, especially using the WebAssembly module. You need to take into need to take into consideration a few things like memory management, like the molecule object you're creating doesn't get deleted right away. And then if you render too many molecules in the main thread, it will decrease the user experience. So with all these abstractions in place, it will set up the table for also framework-specific components that will consume this low-level stack that is more ready for an NPM installed and use experience. So this is the main problem I want to solve. First, there are others. So we don't have a real official API documentation. The reason is because the nature of the project, mainly it's, I think, impossible. Paul, or anyone can correct me if yeah, okay. But having looked into it, like generating automated docs for a WebAssembly module is not trivial, and there doesn't seem to be a de facto way to do it. So there's been an open source initiative that has been contributed by Adam Bairoti, who basically implemented all by hand the TypeScript definition of the API. And with this first version, we're able to deploy a website exposing the API to the public. But I don't think it will be maintainable over time, or I should be more disciplined either way. There's room for finding ways to improve how we can automate the API documentation and make it official once we're confident. And I have an idea on this. I'm 50% sure it can help at this point. But using like the recent advances in large language models, can you pass in a C++ code and ask for TypeScript definition files with a few bag of tricks, and maybe that will at least assist you in maintaining that documentation. Maybe I'm going to try that more. CI/CD, I think it's more for people who develop the library, but we're well aware that there's room for improvement there. In the future, maybe one last thing, I think we're focused on developing a lot of examples for a lot of the same examples in different framework actually for the package. I think moving forward, we should focus on re-centralize our efforts into showcasing potentially new functionalities that are asked by the community or just purely novel functionalities, and also exposing functionalities that are not in the examples or in the API docs, such as the newly reaction depiction features. So you can contribute. Just had a little baby girl recently, so I have less time to contribute actively to the project. So if you're interested, please reach out. You can also contribute in code, GitHub issues, discussion forum, and voila. Thank you.